So in this video, you guys are going to be learning about different rules called theorems related to triangles. One is related to the sides of a triangle and the other is related to the angles of a triangle. So please make sure to watch the video closely, copy down the definitions in your video worksheet, and have fun. So we're going to learn about different theorems that pertain to triangles. And the first theorem is called the triangle inequality theorem, and it discusses the sides of a triangle. So it basically says that the sum of the lengths of any two sides of a triangle has to be greater than the length of the third side. So if you had a triangle and you had sides A, B, and C, it would mean that A plus B would have to be greater than C, or A plus C would have to be greater than B, or C plus B would have to be greater than A. Okay, so any two sides of the triangle, that when you add them together, would have to be bigger than that third side. And then the triangle angle sum theorem basically says that the sum of the three angles of a triangle has to equal 180 degrees, which may not be new for a lot of you, because I hope that somewhere in your past you have recognized that a triangle has angles that sum or add up to 180 degrees. So the third thing I want us to recognize is that the largest side of a triangle is going to be diagonally across from the largest angle, and the smallest side of a triangle is going to be diagonally across from the smallest angle, making the middle side across from the middle angle. So if we think about a right triangle, in a right triangle, the largest angle is the 90-degree angle, which means that the largest side would be what we call the hypotenuse, which is going to be the longest side of any right triangle. If you have an obtuse angle in a triangle, it's going to be diagonally across from the longest side. So we know that in a triangle, if we pick out the biggest angle, we know that the longest side is going to be across from it, and the smallest angle is going to be across from the smallest side. Using the triangle inequality theorem, in order to figure out if it's possible to have a triangle with sides measuring 3 inches, 6 inches, and 7 inches, you would take the two smaller sides of the triangle, which is 3 and 6, and you'd find the sum. Okay, and you would see if the sum of the two smaller sides would be bigger than the larger side. So the sum of the two smaller sides is 9, and 9 is greater than 7. Therefore, it is possible to draw a triangle that has sides measuring 3 inches, 6 inches, and 7 inches. Is it possible to have a triangle with sides measuring 5, 8, and 16? We would see if 5 inches plus 8 inches is greater than 16 inches, and is 13 inches greater than 16 inches? Well, the answer to that is false. So no, there is no triangle that would have measurements of 5 inches, 8 inches, and 16 inches, because if you think about it, you wouldn't be able to draw an angle, because just a straight line of 5 inches and 8 inches, you wouldn't be able to connect it, so any angle would be less than that. And then, is it possible to have a triangle with sides measuring 10, 12, and 22? Well, 10 plus 12 isn't greater than 22, because 22 isn't greater than itself. It's equal to itself. It's not greater than itself. So no, there is no triangle. There's only triangles when the two smaller sides add up to a number larger than the third side or the longest side. If I'm asked to determine if a triangle exists with certain angle measures, I would use the triangle angle sum theorem to determine whether or not a triangle existed, realizing that all my angles have to add up to 180. So if I'm adding up all of the angles, 45, 55, and 70, if I don't get a sum of 180, then it's not going to work. Well, this sum is 170 degrees. So no, it's not going to form a triangle, because a triangle has to have a sum of 180 degrees. Whereas if I have 68, 42, and 70, and I add those up, I do get 180 degrees. So yeah, that there is a triangle possible with angle measures of 68, 42, and 70. So if two sides of a triangle measure 10 inches and 4 inches, what is the range of measurements that the third side could be? So the reason why there's a range of measurements is because we're not quite sure whether the third side is larger than 10, between 4 and 10, or smaller than 4. Okay, so we need to figure out what the measurements could be, recognizing that the two smaller sides have to have a sum larger than the third. So if we were to go through and we were to say, okay, let's say that the third side was 1. Well, 1 plus 4 is only 5, and that's not bigger than 10. So we know that it has to be somewhere bigger than 4, because 4 plus 4 is 8, and 8's not bigger than 10. So in order to find the smallest number that it could be, we're going to subtract the two sides that we're given. And when we subtract the two sides, we know that that's going to give us 6. Now, 6 inches can't be the measurement, but any number larger than 6 can be the measurement. So if we were to say the measurement, if we were to say that x is the third side, then we would say that x could be bigger than 6. Okay, so x could be larger than 6. But it can't be any number larger than 6, because once we start getting too big, then 4 plus 10 wouldn't be larger than it. So the way to find the upper constraint, is to add the two numbers. So when we add the two numbers, we get 14. So we know that it can be anything bigger than 6 or anything smaller than 14, but it cannot be 6 and it cannot be 14. But it can be anywhere between 6 and 14. And the way that we write that using algebraic inequalities is we say that 6 is less than x is less than 14, because the value of x can be anywhere bigger than 6 and smaller than 14. So again, our answer would look something like this, where 6 is the smallest. Anything bigger than 6 is fine. 6 will not work, and 14 is the largest. Cannot be 14. It can be anything right below 14. If two sides of a triangle measure 6 and 20, what is the range of measurements for the third side? Well, we know the smallest it can be is 20 minus 6. So while it can't be 14, it can be anything bigger than 14. And then in order to find the upper constraint, we're going to add the 2, and we know that 26 is the largest it can be. So it basically can be anywhere between 14 and 26 inches, but it can't be 14 and it can't be 26. So x can be anywhere between 14 and 26. So to find the lower, you subtract the two numbers, and to find the upper, you add the two numbers. And just to talk about that very last piece on the first slide where we talked about the largest side and the largest angles, determine if the triangle with sides 5, 10, and 14 and angle measures 25 degrees, 75 degrees, and 80 degrees exist. If it does, sketch it. So the word sketch legitimately means sketch. You're not going to be using a ruler and a protractor. The word sketch just means, do you know that the smallest side goes across from the smallest angle, etc. So the first thing we have to do is figure out if the triangle exists. So we're going to use the triangle inequality theorem to make sure that the sum of the two smaller sides is greater than the largest side. So according to the triangle inequality theorem, yeah, the triangle does exist. And then according to the triangle angle sum theorem, we need to make sure that 25 plus 75 plus 80 equals 180, and that exists as well. So now when I sketch it, I'm going to sketch it so the 5 inches and the 10 inches and the 14 inches. So again, 5, 10, 14. And this is just a sketch. Yours should be prettier than mine just because I'm using my finger here, and you should be using a pencil and paper. And then you're just going to put in across from the 5 inches would be the 25 degrees. Across from the 14 inches would be the 80 degrees. And across from the 10 inches would be the 75 degrees. So you just have to make sure that when you're drawing it, that you're able to label whatever you need to label clearly. And again, that's a sketch. If I wanted you to draw it out, I would say use a ruler and a protractor to draw it. But when you're sketching it, you just have to sketch it. The objective there is for me to make sure that you know that the smallest side is across from the smallest angle, and the middle side is across from the middle angle, and the largest side is across from the largest angle.